This is the homework for 230, 231, 232, 233, and 234. So we're going to multiply these two terms. And you can only multiply when you have like terms. So we have 6 and 4, and then we have exponents with the same base. We can multiply those two. So 6 multiplied by 4, and then 10 squared multiplied by 10 to the 5th power. 6 multiplied by 4 is 24. And remember, when you multiply exponents with the same base, you're adding the exponents. You have 2 10s that you're multiplying together and 5 10s. So 2 plus 5 is going to be 7. Now, when this looks like it's in scientific notation, but in order to be in scientific notation, the A term has to be greater than or equal to 1, but less than 10. Well, 24 is definitely greater than 1, and it's greater than 10. So we have to decrease this value of 24. And so we do that by dividing it by 10, and that will move the decimal to the left, one place value. But if you decrease this, if you divide this side by 10, you're going to have to multiply this by 10. So we're going to add another 10 to this. So 24 becomes 2 and 4 tenths. 10 to the 7th plus 1 is 10 to the 8th. Problem B, we're going to go ahead and multiply like terms. So we have 1 and 75 hundredths multiplied by 8, and 10 to the negative 2nd power multiplied by 10 to the negative 8th power. You can multiply like terms if they have the same bases. So here, 1 and 75 hundredths multiplied by 8 is 14. And then multiplying exponents with the same base, you add the exponents, negative 2 and negative 8. So you determine, do you have more negatives or positives? Well, these are both negatives. So you keep the sign that you have more of. Signs are the same, you add them. So then we get negative 2 and negative 8 equals negative 10. Not in scientific notation, 14 is greater than 10, so we're going to divide this by 10. So we're going to move the decimal place to the left one. So it's going to be negative 1. Well, this is going to be adding 1. So negative 10 plus 1 is negative 9. So 1 and 4 tenths multiplied by 10 to the negative 9th power. Problem 232C, we're dividing in scientific notation. We can only divide like terms. So we're going to go ahead and divide 9 divided by 4. And then when you're dividing exponents with the same base, remember you're subtracting them. And this division bars remind you to subtract 5 minus 7. Well, 5 minus 7, well, 9 divided by 4 first is going to be 2 and 25 hundredths. 5 minus 7, we have more negatives than positives, so you know it's going to be a negative. Signs are opposite, so you subtract. 7 minus 5 is 2. And this is in scientific notation since the A term is greater than or equal to 1, but less than 10. Problem 233A. We have 5x to the 3rd multiplied by negative 3x to the negative 2nd power. Well, all of these terms are being multiplied. So this is 5 multiplied by x to the 3rd. So what I'm going to do is use associative property multiplication to group like terms. And now we have 5 minus negative 3, which is negative 15. Multiplying exponents with the same base, you're adding them. So we have 3 plus a negative 2. We have more positives than negatives, so we know it's going to be a positive. Signs are opposite, so you subtract. 3 minus 2 is 1. And I could put a 1 there for a placeholder for the exponent, but it's not needed. So the answer is negative 15x. 233b. There's nothing to simplify within the parentheses. So we now need to distribute this exponent, 3, to each of these 3 terms. Well, we have 4, and 4 could be written as 4 to the first power. Same with q to the first power, because anything to the first power is itself. And when you're multiplying an exponent to an exponent, a power to a power, it's multiplying. So we have 3 multiplied by 1, 3 multiplied by 2, and 3 multiplied by 1. Well, 3 multiplied by 1 multiplied by 3 is 3, 2 multiplied by 3 is 6, and 1 multiplied by 3 is 3. 233c, to simplify this expression, we have 3 m to the 7th divided by m to the negative first. So the way that looks is we have 7, and when you're dividing integer exponents with the same bases, treat the division bar like a subtraction sign. So we have 7 minus a negative 1. And a lot of people would just write this 7 minus 1, but it's don't forget you're subtracting these two. So it's 7 minus a negative 1. Well, distribute this negative. The opposite of a negative is going to be a positive. So now we have 7 plus 1, which is 8. So it's 3m to the 8th power. Problem 234, which graphs below have a domain, the x values, of all real numbers? So if we look at the x-axis, if it has a domain of all real numbers, that means it's the graph's going to go infinitely to the right and infinitely to the left. Well, graph A shows that. This arrow is going to go forever in this direction, and this graph's going to go to the left towards the negatives infinitely in that direction. B does the same thing. It's going to go infinitely towards the negatives, and it's going to go infinitely towards the positives. So graphs A and B have a domain of all real numbers. C does not have domain of all real numbers because it's starting at -2, and the domain's going to be greater than or equal to -2 because it's only going towards the positives. You're not going to have a value less than -2 because the graph is not going in this direction. Part 2, which have a range, the y values of all real numbers. Well, if we look at y, the range is the y-axis, and A, it's going infinitely on the y-axis in the positive direction, and infinitely on the y-axis in the negative direction. So this has a domain of a range of all real numbers. B is not going past 4, 5, 6. So the range of graph B is going to be less than or equal to 6 because it's only going down. It's not increasing and going towards the positives past 6. C, if you look on the y-axis, this is going to go infinitely up, and this is going to go infinitely down. So graphs A and C have a range of all real numbers. The last part, which are functions? Well, the easiest way to determine that on a graph is to use the vertical line test. And you can see that at no point for graph A are there multiple outputs for the same input. So there's exactly one output for each input. One output for each input. The same with line B. Line B passes the vertical line test. There's exactly one output for each input. But for C, it doesn't pass the vertical line test because you can see here there are multiple outputs for the same input. So for positive 2 has an output of 3 and negative 1. So this is not a function. It does not pass the vertical line test. So graphs A and B are functions since there's exactly one output for each input. They also pass the vertical line test.